Hi, thank you everyone. And I'd just like to thank the organisers for inviting me here. So it's been a really interesting conference and it's my first time visiting Warsaw. So, beautiful city, very lively city. So a great privilege to be here, thank you. Oracle's a huge company. We have around 150,000 employees and thousands of them work on security. But I'm lucky, I'm part of a team that's got a privileged opportunity where a central team, I'm based in the UK, but I work with Oracle worldwide. And our central responsibility is being able to define the standards for security for the whole of Oracle. And so we define a process that should allow Oracle engineers to reliably deliver secure solutions. And so that's obviously going to involve designing things securely, implementing them securely, testing them securely. But the main thing I'm going to talk about today, the focus of this, is one thing we do is we define the security, the cryptographic standards for Oracle. And another thing that we do is talk now, just recently, about AI security. And so those are going to be some of my kind of focuses today. I'm around and would love to kind of talk to anyone if there's any follow-up questions after this. I'm going to talk about these things. First, I'm going to start talking a little bit about cloud. I've been in my role for about 10 years. And those 10 years, the defining feature has been a transformation to cloud. And cloud completely changes, really, the security questions and the security story. And so I've learned a lot about that in the last 10 years, and I want to kind of pass that on. Some of your organizations and applications might be considering a move to cloud, might have moved to cloud, might be evaluating it. And so I want to talk a little bit about that, and then talk about cryptography, AI, and general security at Oracle. Oracle, honestly, wasn't really an early mover in cloud. Okay, AWS was perhaps the earliest mover, and Oracle took a little time to kind of get going with cloud. But we managed to use that slightly to our advantage. The first generation clouds basically, primarily separated users using virtual machines. Virtual machines, can be efficient, but it's not necessarily the strongest way of protecting tenants from another tenant. And so as Oracle built our cloud infrastructure, OCI, we kind of learned the lessons from those that have gone in the past, and we created a cloud, that isolated the network. So we've got a virtual, network that's not connected to hosts, that's not connected to tenants, and that gives us an extra layer of security. If you control the network, even if individual tenancies have problems, those tenancies can't then access the network and access another tenant. The fundamental cloud security question, is that in the standard cloud model, the customer is expected to trust the provider. And that makes a lot of sense for relatively low security issues. I'm a technical person. I could easily set up my own mail server, but I don't do that. My private mail goes through Gmail. It's not important enough to me to put the effort in to try and protect my email, because nothing interesting happens on my private email. But it's a harder question if you're looking at higher security areas. Now, what's happened over the last 5 or 10 years is that commercial customers and some government customers have basically accepted the argument for cloud. Clearly, it's more efficient. Clearly, it's more flexible. But there's also opportunities for it to be much more secure. If you set up an on-premise application, there's going to be configuration drift. There's going to be small issues with individual hosts. The great thing about a cloud network is it can be perfectly standardized. The infrastructure can be defined in code, can be the same everywhere. And it offers greater security. But there's still the issue that ultimately you're trusting the cloud service provider. And so many types of cloud, and this is an example of what Oracle offers certain forms and flavors of private cloud. And one offering that Oracle has is an isolated cloud. So the isolated cloud allows you to have an isolated network, if need be, an air-gapped network, okay? But also that network, okay, can communicate with the cloud. There are particular things called circuits that can allow particular traffic flows in particular directions and provably not allow traffic flows in other directions. And so the isolated cloud hopes to say it can be your data, it can be on your systems, or at least systems you completely control. It can be in your country. It can follow all of your rules. And it can try to also give you the flexibility and efficiency of the cloud. The Oracle offering with this tries to be seamless and easy to use. Okay, if you make things difficult for people to use, they will make mistakes. Okay, and the mistakes will allow attackers in. And so with Oracle, okay, isolated cloud, it basically is the same experience from the user's perspective as the public cloud. And so all the experience that you've gained, okay, on the public cloud, they can transfer here. It's relatively easy to use, and it's just behind the scenes that you get the data isolation. Security is a big part of Oracle's brand. It's something we're very proud of. It's something I'm very proud of because I've worked in it for now an awful lot of years. Any Oracle person giving a presentation tends to, particularly in the US, tends to start with the idea that Oracle's first customer was the CIA. Okay, and so security is kind of built into us from the beginning. And so the way that we approach this is to try and again, make things simple. It should be secure by default, not necessarily requiring an awful lot of work. And so the Oracle systems try to be secure by default. They try to be very, very specific and prescriptive. Okay, there's no point telling someone secure the system. That doesn't really give them any guidance. You need to tell them much more specifically, this is a particular configuration baseline. Every single host on that system should follow that configuration baseline unless there's a good reason not to. And then finally, it's got to be integrated. Customers are likely to be using infrastructure as a service, bare metal servers or hosts, but they're also likely to be using PaaS and software as a service, and they need the same tools across all of that range. Even if you build a perfectly secure system, you've designed it perfectly, you've implemented it perfectly, you've tested it perfectly, that's only the beginning of the game. Unless that system is monitored incredibly closely and incredibly carefully, it will be attacked. There's a statistic, I think I just heard it from somebody else at a conference, but if you put something online, it gets its first attack within 12 seconds. And so kind of monitoring is vital. And another thing that cloud services offer you are integrated tools to do that monitoring. There's no way that humans can monitor at that scale. You've got to monitor 24/7. You've got to monitor every host. And so here, I'm not going to talk through the examples, but there's an awful lot of tools, generally free, that allow you to do that. A secure system isn't secure as soon as it's on the internet. Okay, and so you need these tools to make sure that your systems not just start secure, but end up secure. Okay, let's pivot and tackle the specific kind of topics for this conference, starting with cryptography. Cryptography was my entry into security. I was a maths teacher in my 20s, okay, and I read a few books about cryptography, and I realized this is interesting. I'm quite good at this, and this might be a good job opportunity. And so about 30 years ago, I did a master's in cryptography and moved into this area. Cryptography underpins an awful lot of security. It's one of the few kind of provable areas of security. And so, if you think about authentication, passwords, okay, passwords are generally hashed or like more complicated than that, but in general, passwords are hashed. If your hashing mechanism isn't good enough, your passwords get leaked, and then kind of nothing else matters in your security system. If I can impersonate your admin, all of your firewall rules, all of your access control rules, none of them matter because I'm in as the admin. And so cryptography is the underpinning, I think, of a lot of security. The other part about cryptography is it's complicated. If you set up a system and you have the right algorithm, the right key length, the right mode of operation, but you use an initialization vector twice, and I'm not sure all of you know what an initialization vector is, but this is something very, very complex, low down. If you use an initialization vector twice, the security of the whole system is compromised. And so with cryptography, not only is it complicated, you've got to get 100% right. 99% right isn't good enough. So Oracle has stood up this board of experts, okay? So it's called the Oracle Cryptographic Review Board, okay? I'm a member, okay? The person on my team is a full-time crypto expert, and they're the chair of the board. And we've got a whole bunch of experts from all around Oracle, and they kind of collaborate and work together on creating the standards. And the standards need to change very regularly because attacks are occurring regularly. I don't know how many of you know cryptographic experts very well. They're sometimes quite strong-willed individuals. Can you imagine a meeting of 20 of them together? It's difficult to manage, but I think it works. As I said before, the standards that we use cover all aspects of cryptography. In order to be secure, you've got to use the right cryptographic library. We want to use cryptographic libraries that we've tested, that we trust, that we know are secure. You can download a cryptographic library from the internet very easily, but if you do that at random, it may be backdoored, it may be weak, it may be full of vulnerabilities. And so what our cryptographic review board does is maintains this, and it's pages and pages of information, and it updates it, okay, very regularly. I took a look, I can see all the updates that made. It's been updated more than 100 times this year. And the point is, the standards must be really detailed, okay, they must be updated quickly, and they must be always correct. And that's quite hard to do, and that's why we need a kind of a body of different people, the 20 different experts at Oracle that work on this. A lot of these conferences looked at quantum cryptography. I want to give a different perspective. I'm not a professor, okay? I'm a person that works in industry. And so what I want to do is give you an idea of how these things are kind of happening and working at Oracle. In general, quantum mechanics affects cryptography in two ways. The first way is helping cryptography almost. Quantum mechanics can allow quantum random number generation, which can be more efficient and quicker, okay, than standard. It's a difficult problem, random number generation, as others have said. It can allow quantum key distribution. And I've heard great talks already, in the last couple of days on these topics. Now, for now, that isn't Oracle's focus. As a public company, we're not a university. We're not doing massive blue skies thinking about what will happen in 5 years. We're thinking about what should happen now. And so our focus has been on post-quantum cryptography. The other impact of quantum mechanics is, of course, quantum computers, and quantum computers break various crypto algorithms. And so that's very much been our focus. And the key reason is a particular threat, and the threat is record now, decrypt later. Right now, in 2024, quantum computers are not practically, strong, okay? The number of qubits that we can reliably generate and use is relatively low. The report, I'm sure lots of you have said, some Chinese researchers breaking algorithms, They broke RSA with like 72 bits, which nobody uses. Nobody even uses 512 anymore. So right now, quantum computers are not a threat to the security and the confidentiality of our data. But if the data is going over the public internet, it's easy to record. People can record that data now, and then in 5 years' time, as quantum computers inevitably develop, then they can decrypt that data. Now, 5-year-old data is not as good as fresh data, but there must be things that your organization knows that it doesn't want in the newspapers in 5 years' time. And that's why we need to act on post-quantum cryptography right now, okay? Because this major threat of record now, decrypt later. Specifically looking at what Oracle is focusing on most right now, it's hybrid key exchange. We're really interested in hybrid solutions because post-quantum cryptographic algorithms are new, okay? Because they're new, they're not necessarily robust. If you think about the main classical cryptographic algorithms, RSA, Diffie-Hellman, AES, SHA-2, in some form or other, they've been around for 50 years. AES is obviously only 20 years old, but structurally it's so similar to DES. The general idea has been around. So they've stood the test of time. We don't know, however much mathematical genius we throw at the problem, we really don't know how secure the post-quantum algorithms are. So here we've got one here. We're suggesting ML-Chem. So this is a key exchange mechanism that was went through the NIST competition, has been recommended by NIST. There's every reason to think that this will be secure. Until you remember that NIST recommended an algorithm called Cyc, okay, a year ago. 2 weeks after NIST recommended it, researchers broke it, completely broke it mathematically. Normally, when you do a cryptographic attack, it has a minor effect. It might make attacks 10% more efficient. If it makes attacks 10% more efficient, then it might mean it doesn't take you 40,000 years to decrypt it. It only takes you 36,000 years. But this attack completely broke it. It allowed you to break this algorithm on a laptop. And so what you need to remember is that PQC algorithms are unproven, and it may be wise to use the quantum resistance of the post-quantum algorithms with the proven security of the classical ones. So we're, for example, thinking one of the big things we're working on is, okay, using here, ECDHE, so ephemeral Diffie-Hellman over elliptic curves, mixed with, okay, a post-quantum algorithm proved by NIST, ML-Chem. And the point of this is it can be added to TLS and SSH relatively easily, and this is ready for use almost now. So Oracle Java, for example, is implementing it now. That will be released, okay, early next year. The next thing we're likely to focus on is PQC signatures, okay, another algorithm that was approved by NIST relatively recently. Next topic, okay, artificial intelligence. This tells you a little bit about the capabilities and the offerings that Oracle has. Honestly, it's kind of a sales slide, okay? I'm not going to focus on this. Our interest is security, but certainly 32,000 GPUs, okay, sounds very impressive. But let's talk about the security elements. I'm not going to repeat this too long because a lot of people have talked about it in detail, but there's a massive security risk with AI. First of all, AI, their applications. And so all the normal application security problems relate. Buffer overflows, Java deserialization, all the ways that applications have gone wrong in the past, AI applications can go wrong. On top of that, there are lots of other AI-specific, okay, security problems. Lots of people have talked about this. There was a great talk first thing this morning by Mateus, and hope I'm not mangling his name too badly, on these. And so there's a massive kind of security problem. But I don't want to look at those details. I kind of want to take a step back. The wider problem is that AI systems fundamentally are black boxes. Even the people that create the AI systems don't really fully understand how it works. If I have a traditional system, then I can see if, then, else. And I can very clearly explain to you how the system works. Okay? Generally with AI, we know the system works because the answers are right, but we don't totally understand. So there's a lot of danger there where you present information to an AI at the prompt. The AI takes that information. That information gets embedded into the model and maybe given back to someone later, which you do not want to do, okay, with sensitive information. So on the left-hand side of the screen, I want to talk about the flavor of the month, the thing that in AI that people are talking about right now. Not just at Oracle, across a whole bunch of industries. And so this is retrieval augmented generation. Retrieval augmented generation, RAG, essentially offers two massive benefits over kind of standard AI. What happens with retrieval augmented generation is that you have an LLM, and you ask the LLM questions in the kind of standard way, but you also have some private data, confidential data. Now, you don't pass that confidential data directly to the LLM. Okay, that obviously is the risk we're trying to avoid. You use that data to kind of filter the output of the LLM, and that has two big benefits. First, you keep the private and confidential data from being absorbed into and embedded into the LLM model. And generally, people should be using public models, because it takes so much money, hundreds of millions of dollars, and hundreds of millions of gigawatts and all the ecological problems to develop models. And so it avoids putting your private data into a general model. And secondly, it's a lot less expensive. Okay? If you train a model, or even if you fine-tune a model, that requires GPUs. GPUs are expensive. Everybody wants them. The prices are sky high. And so this RAG model can use a vector database, okay, to allow you to effectively fine-tune the model, certainly fine-tune its output, okay, much more efficiently. Here's an example of kind of how that works in an Oracle database. And so we have a question asked. The question, okay, first gets translated into a vector database. And then, okay, comes the retrieval augmented generation, the private data. The database, your database, then looks at the private data that you've said, this private data is relevant to this model. And you analyze that private data, again, turning it, into a vector database, and then you can get an answer that takes the general knowledge of the AI, the general knowledge of the LLM, but augments it with your data to get insights into your own data, insights into your private data, and basically advice from the LLM that's using both general knowledge from the web and then unique knowledge from your private information. Though AI has security risks and problems, it's basically too powerful to ignore. I'm a bit of a skeptic by nature. I look at things and I think, well, is that really true? Is that really new? But I've been won over in terms of artificial intelligence. Since generative AI, when I first saw it a year or two ago, it's already kind of vastly more powerful. And so despite the security risks, I think we need to engage with AI. And that's something that one of my teams are doing. And so we set the Oracle crypto standards, but we don't want to just set the standards, we want to enforce them as well. And so we have a project which we're going to, first of all, take detailed logs of the crypto calls that Oracle applications are making. particularly easy in Java. You can kind of see all the calls that go through. There's a service called JMS, Java Management Service, that allows that. And then what we're going to do is we're going to basically ask an AI to say, here's a log of the crypto calls. Here's Oracle's crypto standards. Oracle's crypto standards are confidential. Not really sure why, but that's above my pay grade. They're confidential, and I've got to accept that. And we can use the RAG system to do that, to keep the data private, okay, but also then to allow us to do this analysis. And the big advantage we see here is that this allows a kind of interactivity, okay, that other tools don't allow. So you can say, all right, does this application meet our standards? Where doesn't it meet the standards? Which of the violations of the standards are the worst, are the biggest priorities that we should focus on? You can try and fix it and ask the LLM whether that's worked. You can get suggestions from the LLM in order to fix it. And so there are risks, and it's important to use vendors that take AI security very seriously. It's important to take AI security seriously yourselves. But I think it is really important that everybody kind of jumps in. I tell my kids this a lot. Their teachers are telling them not to use LLMs for fear of plagiarism. I'm telling them, don't copy, but do use them, because you really need to start to learn how to use them and how to get the best out of them. I don't give a presentation without showing this diagram. This is my baby. Okay, I've worked for 10 years doing this at Oracle, defining Oracle's secure development lifecycle. And this is the latest kind of, no, not quite the latest, one of the recent versions of it. Okay, this diagram uses the DevOps infinity cycle. Okay, I'm sure you've seen them before, and just basically tries to show how Oracle's security standards fit into this. It attempts to be a coherent and comprehensive model. It's consistent with waterfall models, or as you see in this case, okay, with a DevSecOps model. And this has changed just literally in the last, in 2024, where we had 10 elements to the Oracle Software Security Assurance Standards. Now we've got 11th, looking at the security of AI and looking at the techniques that people can use, looking at the tools that people can use to make sure that the AI systems that are built into Oracle products are as secure as they possibly can be. Okay, that's all from me. Thank you very much.